solving ax squared plus bx plus c equations. So again, our goal in factoring is to help us solve equations of forms that we're not really used to. We're used to solving multi-step equations with one solution. So quadratic equations are written ax squared plus bx plus c equals 0. So remember that solving equations by factoring before, we got the equation equal to 0 on one side. We're going to solve that by using the zero product property. We've already done that. And how do we do that? We set the equation equal to 0, and then we factor. So we're going to use the same steps that we did before, only now we have a new way of factoring a polynomial that looks like this form. So let's put it into play. So y squared minus 5y plus 4 equals 0. So I'm looking here and I don't see any common factor that I can take out of all three of those terms. But I do see that it's in the ax squared plus bx plus c form. So I'm going to look for a product of 4y squared and a sum of negative 5. I notice that negative 4y times negative 5y, two negatives will give me that negative sum. The two negatives will give me a positive product. And you may start to notice that your lists for these get shorter as you kind of recognize what the combination is without having to list all of them out. That should start to happen. You should start to get more efficient at coming up with the pair. So I break this up into my negative 4y and negative 1y. Notice with the plus in the middle there. So I factor this out. I factor this into y minus 1 times y minus 4 equals 0. Then I take each of these factors and set each of those equal to 0 to find my two solutions. Remember we talked about the degree of the polynomial? Since I have a 2 here, I'm going to come up with, at most, two solutions. So here I end up with y minus 1 equals 0, y minus 4 equals 0. I solve each of those and I get 1 and 4 as possible solutions. And if I put those back in there, that should work. We'll try it with this first one. 1 squared gives me 1 minus 5 plus 4. 1 minus 5 is negative 4. Negative 4 plus 4 is 0. That works. If I try with a 4, 16 minus 20, that's negative 4. Negative 4 plus 4 also gives me 0. You should be able to check these. Again, these are really easy to check. Just throw them back in there and see if they work. Let's try another one. 8x squared plus 2x minus 3 equals 0. So again, I want to factor this out. I want to break it up into a product of negative 24x squared. So I've got negative 4x and 6. Notice my list is really short here because I'm starting to recognize some of those numbers that work together really friendly, and I can kind of do the mental math a little more efficiently. And I know that negative, I need one negative and one positive. The positive has to be larger because I have a positive sum here. And I notice that negative 4 and positive 6 are 2x. If you don't just see it, write out the list. There's nothing wrong with writing out the list if a certain combination doesn't come to you. I break it up. I factor. I come up with 4x plus 3 times 2x minus 1. I set those each equal to 0. I solve each of those equations, and I come up with 1/2 as one solution and negative 3/4 as the other solution. Okay, so those came from my two binomial factors here. All right, two more. All right, I have to stop using the letter p in here. 2p squared equals negative 21p minus 40. So you'll notice that this equation is not set equal to 0, so I need to move things over here. I like to have the a term be positive, so I moved everything over to keep that 2 as my leading coefficient here. So I have 2p squared plus 21p plus 40 equals 0. So I don't have any common factor I can take out of all of those. So I'm going to see if I can split this up since it looks like ax squared plus bx plus c. Notice I'm getting a little bit lazier here with my tables. Now because I left out the variables in there, I just went with the coefficients. But I looked at 80, a product of 80 and a sum of 21 and said, are you kidding? There is no possible combination. This one's going to be a no solution because I can't come up with it. However, I listed them all out. And once I started to list them all out, I got to 5 and 16 and went, oh, of course, 5 plus 16 is 21. So if you think there is no possible combination, please list out all of the combinations that there are. That's going to be the only way you're going to prove to me that there's no possible combination, because sometimes you just don't see it. So I had to list them all out before I got to 5 times 16. So I broke this up into 5p plus 16p, factored those. I have these two factors, p plus 8 and then 2p plus 5. Broke those into two equations, each equal to 0, and I come up with two solutions, negative 8 and negative 5 over 2, or negative 2 1/2. Last one, negative 8x plus x squared equals 9. Again, we're going to set this equal to 0, so I subtracted the 9 from each side. when I redid this, I rewrote this so it was in ax squared plus bx minus plus c notation, so it was in that standard form, is equal to 0. So then I realized I needed a product of -9 and a sum of -1. When I broke that down, I came up with 1 and -9. That has a sum of -8. Now, if you've noticed, and you may have noticed this as we've done this, if your coefficient, if a is a 1, well, the only way to get this to be 1 is to have the coefficients here be 1, because I can't put anything in the front there and get anything but 1x squared. So I know these are going to be 1s. These are going to be the back end of your binomials here. So these are both going to be x's. You can fill in one binomial with the +1. You can fill in the other one with the -9. You just fit them right in there if you notice that pattern. If you don't notice that pattern, do it out this way. You'll get it. So these are my two factors. That's equal to 0. I'm going to break that up into two equations that are both equal to 0. And I come up with x equals -1 and x equals 9 as my two solutions. So using that pattern of ax squared plus bx plus c to factor my polynomials so that I can solve for an equation. Setting the equation equal to 0, factoring, and then setting each of the factors equal to 0 to come up with my solutions.